All right, let's dive into something pretty out there, a brand new theory that tries to solve some of the biggest puzzles in the universe. It's called the S-Matter framework, and it all boils down to this one totally mind-bending idea, a fifth dimension. So get this. What if the stuff we can't explain, like, the invisible dark matter holding galaxies together, or the mysterious dark energy pushing everything apart, what if they aren't actually things in our universe at all? What if they're just shadows, spilling over from a reality just beyond our perception? That's the core question we're going to dig into. Okay, so why do we even need a wild new theory like this? I mean, don't we have a pretty good model of the universe already? Well, yeah, we do. To understand why, we have to talk about the current champion, the standard model of cosmology. And look, it's been incredibly successful, but it's got some serious cracks, some really profound unanswered questions. First up, there's dark matter. We know something massive is out there. It's like this cosmic glue. We can literally see its gravity holding galaxies together, stopping them from just flying apart. But here's the catch. We have absolutely no idea what it is. It makes up something like 85% of all the matter in the universe, and yet totally invisible. And then you've got dark energy. For the longest time, we figured the expansion of the universe should be slowing down, right? Gravity pulls things together. But nope, it's doing the exact opposite. It's speeding up. Dark energy is basically just the name we slapped on this phenomenon, because honestly, its physical cause is one of the biggest mysteries in all of physics. Period. The standard model also has this origin story. It points back to a beginning, a big bang, that started from a singularity. But here's the thing about a singularity. It's not a real thing. It's a mathematical dead end. It's the point where our equations just throw their hands up and break. Our own laws of physics basically admit they can't describe the very beginning of everything. That's a huge problem. And if that's not enough, we've got the Hubble tension. This one's a real head-scratcher. When scientists measure how fast the universe is expanding today by looking at stuff nearby, they get one number. But when they calculate it based on what the early universe looked like, they get a different number. And we're not talking about a small rounding error here. It's a major disagreement that strongly suggests we're missing something fundamental in our understanding. So let's recap. We have four massive, universe-sized puzzles. The S-Matter framework comes along and proposes something totally radical. What if these aren't four separate problems? What if they're all just different symptoms of a much deeper reality we've been completely blind to? The core idea is this. Our four-dimensional universe, that's 3 dimensions of space plus time, is not the whole shebang. It suggests our universe is actually an open system, kind of like a single current in a vast, vast ocean. And it's constantly interacting with this timeless 5-dimensional reality. Okay, this whole idea is built on 5 core principles or postulates. Let's walk through them. First, the 5th dimension isn't another place you can go to, but a timeless domain of pure potential. Second, the fundamental stuff of everything isn't atoms or quarks, but something called S-energy. Third, our universe? It's just a projection of this energy, and what we call time is simply that projection unfolding. And finally, the last 2 postulates tie it all together. They say that matter and energy are constantly cycling between our 4D universe and that 5D source. This is huge because it means the law of conservation of energy only works if you account for both systems together. So how does that even work? I mean, if our universe is an open system, there has to be some kind of mechanism for this exchange, right? Well, this theory describes exactly that, a constant, two-way flow of energy between our dimension and the 5th. Think of it like a cosmic engine, always running. And this engine, this cosmic cycle, it works like this. On one side, you have the inflow. The theories suggest the huge empty voids of space aren't really empty at all. They're actually the main entry points where new energy and space are constantly seeping into our universe. And on the other side, you had the outflow. The super dense spots, yep, black holes, they act like cosmic drains where matter and information go back to their 5D state. So in this model, a black hole isn't this scary point of infinite density. It's something called a resolution point. It's basically the place where our 4D reality just gives up under extreme gravity. The projection stops, and the information that makes up all that matter gets returned to the timeless 5D source code, if you will. Now, you might be thinking this inflow of new matter must be a massive gusher, right? Actually, it's the opposite. It's an incredibly slow trickle. We're talking about something like 1,000 new hydrogen atoms per cubic kilometer every 1,000 years.
It's almost impossible to detect. But, and this is the key, when you scale that tiny trickle up across the unbelievable volume of all the cosmic voids and over billions of years, that trickle becomes a universe-shaping flood.
Okay, so this idea of a continuous cycle, it completely changes the picture of how the universe began. It means it wasn't a hot, explosive Big Bang. It was something else, something totally different. And this table really lays out the key differences. The standard model we all know starts infinitely hot. This new model starts at absolute zero. The standard model builds everything from the bottom up, small particles clumping together to form bigger things. This new model is top down, with the largest cosmic structures forming first, like a scaffold. And maybe most importantly, matter isn't just on a one-way street from creation to decay, it's in a continuous bidirectional cycle.
All right, so we've got this wild new model of the universe. It's a cool story, for sure. But does it actually solve the problems we started with? Let's circle back and see if it can explain those dark mysteries.
First up, dark energy, that mysterious force that's accelerating the expansion of the entire universe. So what is it according to this new idea?
Well, it's not some mysterious energy field after all. In this model, dark energy is simply the physical effect of that constant inflow from the fifth dimension. You've got new space and energy always being injected into the cosmic voids, creating this kind of hydraulic pressure that's literally stretching the fabric of space-time and pushing everything apart. It's not a mystery force, it's a physical consequence.
Okay, that's one mystery down. But what about the big one? What about the other 85% of matter we can't see? What is dark matter? Right, so according to this theory, you're never going to find a dark matter particle in a collider. Because it's not a particle. It's the raw gravitational influence of that S energy itself, projected from the fifth dimension. You can think of it as the geometric stress on space-time, the invisible scaffolding that normal matter is drawn to, but which hasn't actually condensed into the particles we're familiar with. So that just leaves one final puzzle on our list, the Hubble tension, where the two different methods for measuring the expansion rate just don't agree. How does this model handle that? Simple. The theory claims both measurements are actually correct because the expansion isn't uniform everywhere. Remember how that inflow of new space happens mainly in the low-density voids? Well, it turns out our local patch of the universe is sitting in a less dense area. That means the inflow is stronger here, which leads to a faster local expansion rate. The tension isn't an error at all. It's a predicted feature of this whole model.
And this is absolutely crucial. This isn't just a neat story or some philosophical idea. It's a real scientific hypothesis with specific testable predictions. It predicts that cosmic voids should actually bend light more than we expect. It predicts that we should be able to find clouds of brand new, pristine hydrogen hiding out in those voids. And it predicts that if we could measure it, the expansion rate inside a void should be even faster than what we see here. These are things we can actually go out and look for. So look, whether this theory turns out to be right or wrong, it forces us to ask a pretty profound question. Is everything we know our entire reality from the beginning to the very end? Is it all just one single fleeting current that's been made real from a timeless five-dimensional ocean of pure potential? Now that is a thought to chew on.